Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syahri Miswaimi. I'm from J4EM1104H, and today I will do a video about MEM360, which is lab 4. Let's look at the first page. For this lab, we have two parts, which is part 1 and part 2. And for the material, for each part is steel low carbon 1005. For part 1, the process is actually a milling process, and for the step that I choose is number 1 face mill, number 2 center drill, number 3 which is drill, and number 4 tapping, number 5 rough mill, and the last one number 6 is finish mill counter. For part 2, which is a turning process, the step that I choose is number 1 rough face, number 2 finish face, number 3 rough turning, number 4 finish turning. After that, with number 5 center drill, and we followed with number 6, which is the drill, number 7 tapping, number 8 rough boring, number 9 finish boring, and the last one, which is number 10 cut off. I choose the part 1, which is a milling process, and the step that I choose to be explained is part 5, which is the rough mill. For the cutting tool, I choose the ball nose end mill, and the reason I choose this cutting tool types because the design of the cutting tools is suitable with the shape that we want to make, which is such a irregular shape. Okay, for the description for the part B is MRF 16S20-160, and the number of insert of flute for this for this part is 1, because except for the drill, all the insert of for the flute is 1, and the size of the DC, which is the dimension in mm, is 16. The LH and LF for the dimension is LF 160 and LH 65. For part C, the cutter material is carbide. The end mill diameter is 16 millimeter. The machine max we can choose between 5,000 to 6,000. So I choose 6,000. And for the flute, for the cutter is 1. After we done the calculation in the software, we got the answer such as cutting speed, which is 107 meter per minute, the spindle speed 2120 rpm, the chip load 0.096 mm over flute, and the feed rate is 204 millimeter per minute. And for the estimated time, which is length of cut, we divide with the feet. We divide it in 180 millimeter. We divide with 204 millimeter per minute, and we got 0.88 minute. Okay, and the part D is the sketch of the result from this process. Okay, I hope you guys understand with my explanation, and that's all from me. I want to say thank you and goodbye.